Kubernetes manage TLS certificates, it's a certificate authorities and certificate signing request, which is called CSR. So before going to the TLS, let's try to understand HTTPS and where the TLS comes into the picture, etc. So let's say you have one browser and there is a web server. So you are trying to hit some website. So your browser, typically a Chrome browser or any browser which is loaded with all the public CA certificate authority here. So and as well as wherever the website you are trying to hit, say youtube.com, kubernetes.io or any website you are trying to hit, this website is exposed as a HTTPS. How? This will have a one web server certificate which is signed by this guy, this certificate authority, right? So certificate authority will have a store here in the browser side and server side, which is a signed certificate. Whenever you go and hit from your browser URL, this is a client, this is a server. Now this client sends a request to this server, hey, I wanted to hit your server. Then this server will send back the response saying, this is my certificate and this is my public key, and this server will send back to the client. Now what the client will do, client means your Chrome browser, which will verify against the CA, which is the certificate authority, whether this particular guy whatever sent, which is a legitimate or not. Then once it is verifies, then this will send back, client will generate one encrypted session key and send back. Then after that, server will send, yes, whatever the encrypted key you sent, which is specific to this guy among the crores, billions of users. Then server will, yes, acknowledge, and then both guys are acknowledged, then both the communications are encrypted. So this is the communication, is basically a typical HTTPS communication, how it will work, right? Then so here this is in the HTTP layer, which is application layer level. If you look at the OSI 7 layers, which is the middle layer is a transportation layer. So application layer to the request will be forwarded to the transportation layer, which is in the transportation layer level, TCP connection will be established. So how it will be is, this is your web browser and this is your web server. First TCP connection. So this web server will send some request which is called a sync, and acknowledgement is no acknowledgement. This guy's browser will send some number, and then web server will return back with some other number and increases this browser's number and says yes, acknowledge. Then after that, this guy browser will send back server's number incrementing by 1 and client number and send back to the server. So this is called a TCP connection established, just a connection only, a physical connection, you mean, alright? So once this step is complete, both the parties will assume that yes, there is a connection is established. Now second is a TLS. This is also called a TLS handshake process as a second step. What happens is, you have a browser and you have web server, right? Then first browser will send a hello message to the web server, right? Then server will send back, yes, hello means hello. Then this web server will send a certificate to the browser, and that certificate and also requests a browser's client certificate. Then this browser will send the certificate back to web server, right? To why they are asking each other to identify each other, mutual TLS. So and client, basically what this client will send is, there is some cryptographic hash value this browser will generate and send it to the server. Now client will say yes, I am done, I am finished. Then after that, server also will say yes, it's finished. Then after that, both the parties will use this cryptographic hash value, and all the communications are encrypted by using its own keys, right? And this is called a request response, and both are encrypted. This is how a typical TLS handshake process This is the very high level. Now next is a certificate authority, right? In the first step we have seen. So basically certificate authority point of view, there will be a root CA, right? Say if you go to the browser, say this is my YouTube, and say I open my certificate, right? So this is a root CA. Root CA is given by whom? If you look at the details, right, issued by Google Trust LLC, and there is an intermediate CA. So let's go back here, right? This is a, say if you go to the kubernetes.io, which is the same case, right? I'll close this is kubernetes.io, right? This is Kubernetes certificate, right? So this is a root certificate, right? This is a root certificate, and right, then this root certificate basically usually it's a self-signed by its own organization, and root certificate signs intermediate CA, which is the middle one, which is this is the one. If you select R3, it looks like that, and the issuer name will be there here. So if you go here and if I select intermediate CA issuer is who? The top level guy, right? And this certificate is valid up to 2035. This certificate is valid up to 2025. So these are 20 years, this is a 10 years, right? And this is a just typically 1 year, like that. So root CA will signs intermediate CA, and intermediate CA signs the actual server certificate. So that this is how the CA will work, and that's how the trust will be established based on the issuer and to whom it's issued, etc. So if you drill down the more details here, right, scroll down, this particular kubernetes.io certificate issued to the its basically it's a domain name, right? If you scroll down here, right, its algorithm and all will be there, DNS name kubernetes.io, www.kubernetes. So whatever all the kubernetes.io and as well as its website www. So this is how the typical CA looks like, right? Then certificate signing. So as in the first step we have seen that the signing process, right? So how the signing will happen is, you will be creating one public key and private key. This is called a key pair. Key pair means one public and one private. Public is always public, private is always a private. You will be keeping secretly, storing, you are not sharing with anybody. So public key, what it tells is who you are. Say I am GVR, right? This private key is some encrypted key. So why the private key will be used? Private key used to prove who I am and as well as a decrypt, right? Then what happens is, this public key will have some identity information. Then you will be raising a CSR, which is called a generating a certificate signing request to whom? A certificate authority. Say I wanted to create my certificate for my website, so this is how I will do. Then with my identity information, the CSR will be sent to certificate authority. Certificate authority again they will have one private key, and certificate authority what it will do is it will sign and give me a signed certificate. So in this process I just generated with my information, but this guy is given a signature, and this is a signed certificate. So this signed certificate I can use in my web server, we have seen in the first step, right? So this is how the certificate signing process happens. Now signed certificate how they will give, just now we have seen, right? So in the Kubernetes, say let's go to the YouTube, right? This is YouTube, right? And certificate and connection secure here, and I'll just expand details, right? This Google common name is this, but when you scroll down here, alternate domain names, right? Same certificate will be used for star.google, API engine, bdn.dev, right? There are many Google CA, CL, co.in, co.jp, co.uk, right? So for these all domain there is only one certificate, is a signed certificate, right? So that's how the signed certificate will be given to its alternate domain names, so that this website can use. Now let's come to the Kubernetes CA. So that's what the topic we are. So Kubernetes CA. So basically CA point of view, there are two different types of CAs. one is a public CA, which is used for the websites, and there is a private CA. So public CA, right? Say for example, kubernetes.io is some website, let's consider, and this kubernetes.io is a public website, all the developers are using, right, day to day. So this is issued by, if you go scroll, expand the details, this organization is Let's Encrypt, is one of the bigger organization. They guys signed and given, this is the public CA. And where the private CA used within the organization, say I am working in one company has say 10,000 employees, and say out of 10,000 there are 5,000 Kubernetes clusters. All the clusters should use a one CA, which is issued by the one organization. So you can create your own CA, same like this, and use it between your organization, within the organization. That's how whenever you create a Kubernetes cluster with say one master node and one worker node, it will use internally a private CA for its components. What are the component means? Component means it's Kubernetes API server, etcd, right, controller manager, scheduler. These are the Kubernetes component if you look at the Kubernetes architecture, right? And Kubernetes have a CA, which is a private CA, its own CA, which is typically a second level CA. So that means this is a root CA, intermediate CA, and the server cert. So within the organization level, you will be using a one intermediate CA. That's enough. There is no root CA, right? That's how the Kubernetes will use, and we'll see and we'll prove as well. So this Kubernetes CA creates a certificate for all the components, right? And what are the certificates it will create CA? One is a server certificate. When I say server certificate, means one certificate and one key file. So key file is always there, just remember. And one client certificate means API server. API server is a server, and as well as it works like a client as well, right? Say I own a one shop. I am a boss for the shop, but when I go and buy somebody other shop, I will become a customer, right? I'm a client. So same likewise, Kubernetes exposes these two different kinds of certificates. If it is a client certificate signed by the CA, server certificate also signed by the CA, as simple as that. And every certificate will have a key as well. That's what this red colored key. Now next, Kubernetes CS. Yeah, so if you go to the Kubernetes master node, right, so I'm in a Kubernetes 2 node Kubernetes cluster, right? Now I will go inside the master node, right? So I'm SSH inside the master node, just bear with me a second. Yes, I am back here, right? So now, so where the Kubernetes certificates are stored in this particular location, right? Say cd etc Kubernetes, right, and pki, right, say ll, right. When I do the long list, these are the certificates are stored, and this is a centralized location where all the certificate will be used. Say let's say tree, right, here. Now first, ca.certificate. What is the ca.certificate? This is a root CA for whole Kubernetes cluster. This is the number one, and this is the ca.cert. This is the ca.cert, which is located in this location, right? That's the number one. Number two, there is a folder called etcd, right, which is this is the one. Under etcd there is a CA cert and CA key. So what exactly it is? This is a second CA, which is etcd CA we will call. So CA is a completely root CA, and etcd is only for the etcd CA. Now this Kubernetes root CA, what it will do? It will create a server certificate and a client certificate. It will sign basically, right? This as a root CA means it's a boss, so it will sign. Right. Now if you look at the carefully here, there is a front proxy CA. right? So you see here front proxy ca.crt and client. So Kubernetes is also maintaining a front proxy CA as well. So front proxy CA is basically to communicate with the external users. Whenever external users connected to the Kubernetes, then this CA will be used, right? But overall idea is here Kubernetes maintain a 3 CAs, 1, 2, 3. HCD is for HCD. HCD is a key value store database, right? And HCD has a health check client. Means this HCD connecting to the some health check server by using this certificate. You got it? And there is a peer. This HCD exposes there is a peer server and its own server. So HCD has a different functionality and it has its own certificate. But point is it has a own CA. Now next. So Kubernetes have a 3 different CAs. Now if you wanted to see that, how to see that? Kubernetes Certs check expiration command will tell you the. So let's do that. Sudo su. So I need to be the so kubeadm, right? Certs check expiration. Certs check hyphen expiration. Right? So when I do the kubeadm check certificate expiration, right? Here, that's what of course the same diagram which I kept here, right? Certificate authority. How many certificate authorities are there in my Kubernetes cluster? One is a CA, which is called a root CA, which is residual time 9 years validity. HCD CA is 9 years, and front proxy CA also 9 years. This is specific to the my Kubernetes cluster only. If you create in your local machine, since I created this cluster in my local machine, this local is Mac. So if you create, then it will be the different and its certificate everything different. Now there is a admin API server. This API server is signed by whom? Root CA, which is this. HCD signed by whom? HCD CA. Yeah, of course there are 3 CAs. Yes, just now I was in scheduler. Scheduler signed by whom? CA. What else? API server will connect in Kubernetes, right? Those will be used its CAs. So I hope this will give you the some idea, right? And its expiration. So usually this will be typically 1 year, and then after the 1 year it will be automatically renew, right? And there is a renewal command as well. Kubernetes certificate renew some the document. Yeah. So this is the Kubernetes component, right? So if you look at the API server will have a server certificate, client certificate. HCD, just now we have seen server certificate and client certificate. And Kubelet, where the Kubelet will reside? Kubelet will be residing in the individual worker nodes. So every Kubelet also have a server certificate and client certificate, right? So this is the diagram which I have taken from official documentation. Just go to the Kubernetes and search for Kubernetes component, then this diagram will show. Just I added this, right? So and controller manager is basically it doesn't have anything, because this API server is talking to the this component which is internal component, right? So whatever is, so here Kubelet, how it's talking to API server? By using its client certificate. Whenever API server wanted to talk to this guy in this direction, then it will use as a client certificate to connect to Kubelet. Kubelet also have a one server certificate, right? Because there is sometimes API server also need to talk back to Kubelet, right? So both the directions the communication will happen, and in this communication will happen via this API server will have a HCD client certificate and connecting, because API server will inject the entries into the HCD database, right? That's why HCD exposes these 2 certificates. Of course, otherwise if it is nobody is using, then one server certificate is enough, right? So why the client? If anybody want, the customers of this guy will use as the client certificate, as simple as that. Now Here worker nodes. How the worker node will get a certificates? Let's say I have a Kubernetes cluster, one master and one worker node, right? I have added a new worker node due to my workload I wanted to handle. How this worker node will join, and this Kube API server will recognize that this guy is also part of our group. So what the Kubelet will do is, Kubelet create a CSR. Same, the first step what we have listen, same. Kubelet will create a certificate signing request by using there is a API exposed by the Kubernetes, which is, let me show that, right? So this is a certificate signing request, CSR, and if you go here and this documentation is there, and there is a TLS authentication, so it's there in this particular documentation. So this is the first, it will create one CSR by using this API, means this Kubernetes API server exposes one API endpoint to create a CSRs to this guy, because here our intention is to this worker node to joining into this group, right? Like a new joiner in the organization. So Kubelet will send here by using this API. Second, send it to API server with what information? System.node and dollar of instance. So this instance whatever, because this instance name could be anything. How this master guy should know this name? So right, system.node.instance, and it will send to master node. This is an identity of the, and system.node is a group. It will tell entire Kubelet that, hey API server, one worker node is joined in our group. This is the, please add it into the system.node group with its ID. Then Kube API server, it will sign and approves the request with a built-in signer. So of course he is a signing capabilities. If you go to the bank, only few guys only have a signing capabilities, not everybody, right? Like a bank manager, where you apply for the loan, the finally when bank manager will signs, then your loan is granted, something like that. So this guy will sign and approves with a built-in signer. Whenever Kubelet communicates, it's automated auto approves, right? And once this is signed, then that whatever the signed certificate will be used by the worker node, and then all the communication will happen. Here once it is signed, you can download it and use it. Now Kubernetes communication, right? So here in the Kubernetes there is a API server, and of course it's etcd, as we have seen in the previous. API server will have a root CA, yes, we have seen in the right here, root CA. Then second is a server certificate and client certificate, yes, we know. And etcd also will have a etcd CA, server certificate and client certificate, yes, we know that, we have seen in the previous slide. Now this is a node, say worker node 1, and where the Kubelet is reside, right? So this Kubelet will use client certificate, and all the communications to the API server are encrypted by using a TLS communication, because same, the initially whatever the procedure we have seen, right? TLS, three-way handshake and communications. So this is between the transportation layer, right? Because already there is communication. And say, let's say there is a one pod, right? This is a Kubelet. Let's say you have one pod is running, and this pod has a default service account and config map as well, right? And this pod wanted to talk to API server. How it will use? This will use a CA certificate and SCA token. What exactly it is? So let's prove that. So I'm getting out of my server. Say let's say kubectl get pod. So when I say get pods, right, there is a hello world pod is running, just simple hello world pod, right? So kubectl, right, describe pod and hello world, right? Simple enough. If I open a hello world pod, right, just scroll down a little bit carefully. Yeah, better what I will do is kubectl get pod, right? kubectl get pod and hello world, right, and then -o YAML. I wanted to see in the YAML format. Now see, this hello world pod has there is a volume mount of service account. What exactly? This is a one. Just please note down. This is a one. Second is, if you scroll down, right, volumes, right, and there is a config map also mounted as a volume, which is this is a config map, right, kuberoot ca.crt, right, there is this is a config map is mounted, right, two things, one is a service account and second is, so let's copy this, and what I will do is I will go inside the pod, kubectl execute in interactive way, and hello world and bash auto completion is enabled, right, and now I will go inside the pod. Now I am inside the pod. Now first service account, what is exactly the service account? Let's copy this, right, cd, I'll change it to this directory. Now ls, 1 2 3 files are there. One is cat ca.crt. What is the ca.crt? This ca.crt is mounted from kuberoot ca.crt. How to prove that? I will open a duplicate tab, right, now kubectl get config maps in kube system namespace. So what is this? It's a kuberoot ca.crt. This is, which means whatever the root CA certificate is exposed as a configuration map, since it's a public to the within the cluster. Same, so if you wanted to, if you are interested to know the how it looks and all, right, describe config map kuberoot certificate, right, kuberoot CA certificate. Now enter. Start with MIIC and ends with the YR9. Let's go back here. Start with the MIIC, end with the YR9. Perfect. Right now, and the second is what? A token. Right. Cat token. This is a one token. So this token is from the secret. Right. Say let's say kubectl get secret in default namespace. This is a default token. What is this token? Service account token to communicate with the Kubernetes API server. As simple as that. So that means, let's go back to the slide. This pod using a CA certificate and service account token, these two, to communicate with the API server. As simple as that. Right. So whenever I am creating a hello world pod, I did not specify anything. I just kubectl run, then this is a container I given, that's it, it's exposed. Now next, this is a kubelet to kube API server communication. Now there is a kube config, right, say let's go here and then say clear, say kubectl config view, right, this is a my kube config file where I am connected as a kube admin, right, kubectl config current context, I am just connected as only one guy, Kubernetes admin, right. This one, right, here whenever I connect from the kube config file, I will be using a client certificate and client key. This is, and also I can use a token as well. This two ways either. Now then after that, this kube config to here the communication is happen via again the TLS. So if you look at the my kube config file, kubectl config current context hyphen kubectl config view, right, and hyphen ra. If I do that, it will show me the actual values hyphen ra. So if you scroll down here, Kubernetes admin user means this guy is using a two certificates, client certificate data, client certificate key, right. So which is these two, client certificate, client key. then I am communicating with the API server. So right, my servers are located in a different place. I am connected from the my local MacBook, right? Maybe if I share my kubeconfig file, you can also connect from the my local area network. So this is how the communication will happen from the node to kube API server, and kubeconfig means from admin to kube API server, right? And you can do kubectl apply, do something, means it will just do. And internal communication happen between a kube API and its CD is a internal communication, which is CA, right? Now so we have seen in the previous slide CSR, right? CSR, how it looks, right? So if you go to the Kubernetes documentation, certificate signing request and manage TLS certificates in a cluster. So if it's the certificate signing request, scroll down, there is a CSR which is created, right? Maybe I will show here. Yeah, there is a certificate signing request. This is right. So let's try to understand. So means if you wanted to achieve this guy or here to here, anything you wanted to communicate with the kube API server, you need to create a CSR. How you will create? By using this is the YAML. So here kind is a certificate signing request, and you will give a some name group. So here what I am trying to do, I am trying to create a user as a Venkat. So see here kubectl config current context. So here in the current context, admin is here. So I wanted to create a user as a Venkat, and he want to be part of a system.authenticated group, which is a CSR YAML definition has. Second is a request. Who is requesting? Venkat.csr. So first I will create my own CSR, right? Then I will base64 encode and just send it here. Then signer. I am asking whose signature? Kube API server client. So in the Kubernetes CSR, there are signers. So here my use case is what my target. I wanted to create a one user which is as a Venkat, right? As a kubeconfig user. So I just wanted to use as a client authentication. So if you wanted to know about this particular details, right, this is the CSR. Then second CSR, another example, right? So you just look at kubectl explain. This is the best way, right? Say certificate signing request. When I kubectl explain, right, and it's a definition and all, maybe you go and read that, right? And it's a spec. I am most interested in the spec. So now dot spec, right? When I do the dot spec, right, here, right? So first groups, whatever the request, group membership, okay? And if you don't specify, automatically this will be populated. And the request is basically whatever the certificate request PEM block. Here it's clearly mentioned, right? PEM block, which is a PM certificate. Then signer, right? Signer. So I am creating a CSR, but who sign, right? One is Kube API server client. Second is Kube API server client kubelet. Then means API servers client. Second is kubelet's client. Then kubelet serving. So these are the three different signers, but you can create your own signer as well. Yes, there is a fourth one. You can create your own fourth one, right? So yeah. So here there is another CSR, which is I want to be a part of system.authenticated, and I created some hello world server. I created hello world application. That hello world application wanted to be called by the API server. Means API server will call this hello world application. In that case, I need to have some authorized, right? So like admission controller I am creating. So admission controller is connecting to hello world. So in that case, I will use the signer as whose signer, external signer, which is learnwithgvr.io.serving, which is I just given a domain. And these are the usage. And another important is the usage is here, right? Usage. For what purpose you will use it? Request for TLS client certificate, request for serving a TLS certificate. I want the certificate for serving, not for the client. In the previous example is a client. Previous example is what? This Venkat is a user, he is a client for Kubernetes server. But whereas this is serving the certificate, which to be called by Kubernetes server, right? He is not calling. Kubernetes server will call this particular hello world. So in that case, usage you will be specifying digital signature, key encryption, and server auth, right? In the previous one you see client authentication only, right? So that's what this documentation is said for what is the purpose you can use that. And there are various valid purposes as well, valid use cases, right? I hope you get the what is CSR. Now CSR signers, as we have seen in the just now here, there one is a Kube API server client, second is a Kube API server client Kubelet, right? And like a kind of a Kubelet is being called by the API server, so that's second one. Third one is a Kubelet serving. So Kubelet serving is also one of the serving basically issues for the TLS endpoints. Yeah, so these are the three, and there is a custom signer as well, so which is a learnwithgvr.io, the serving. Now CSR key usage, as we have seen, right? This usage. So all the valid values are, these are the values. Say if you wanted to do for email protection or MIME, so there are many. It's a very advanced topic where if you wanted to implement some custom plugin for the Kubernetes as the admission controller, then you can specify its certificate and use for that, right? So yeah, and then TLS client, these three use, TLS serving, then use this. So that's what the as per the documentation. Now CSR command, kubectl get CSR, kubectl describe CSR, right? So if you go here, right, kubectl get CSR, right? So this one. So and these are the commands, and if you go to this official documentation, right, which is this GitHub, this is the what the which is yeah, this is the one, Kubernetes enhancement, and there is a diagram, this is the one. So basically so before going that, let's go the steps. So basically I have a Kubernetes cluster. So what I will do, I have created a certificate key pair using a CFSSL. So first step is I have to create a certificate pair by using a CFSSL. What is CFSSL? Which is a Cloudflare SSL. Why we need to use apart from OpenSSL is basically this is developed in the Golang, and which has a more secure features, and you can do the self-signed custom CA and all. And in the Kubernetes the hard way, in here also if then they have used, and it has a very more capabilities than the regular OpenSSL. You can go and explain. So whenever you create a certificate pair, it will create one CSR and key file or PEM file. That's the first step. Second, you will create a certificate signing request, which is, go to the documentation, which is something like this, and we'll see the demo as well. Now third is, then once the certificate signing request is done, then you will be approving. Then second, here I wanted to use as a custom CA. I don't want the existing signers. So here signers are 3 people. I don't want that signer. I want to use my own signer. So this one. Or if you wanted to use existing signer, then custom CA creation not required, because already you are existing, right? It's a custom CA. Then after that you will be signed with the CA. Signing with the CA to whom? This is certificate which is approved certificate. Then next you will upload, once the signing is complete, you will upload the signed certificate to the API object level so that it will reside. Then download it and then use it. Where you will use? You will use as a secret in the pod, right? So overall purpose is, what's the purpose I am doing, right? This is what's the purpose. Say here when I say use it, and so why I should use this CSR, right? So use cases, example use cases only, there may be a many. Say I wanted to create a kubeconfig user, which is a Venkat. here Venkat is a user, he will talk to kube API server, right, as we have seen, right, kube config user. Now second is, I wanted to create one hello world XYZ service as admission controller webhook. In that case, kube API server will call this guy, correct? It's a reverse direction. In that case also I need a certificate, right? That certificate how you will create? By using a CSR. Now XYZ service from ABC organization, say dual communication I want, also you can do that. So it's like you are authorizing your own certificates with the Kubernetes, right? Now the demo time. Alright, so now I'm in a 2-node Kubernetes cluster. So I have a service called hello world SVC which is running in my cluster, and its specific pod hello world. It's a very simple pod. So my objective is to this hello world SVC, I wanted to create one certificate. I wanted to host this hello world SVC as a secured server. I wanted to expose as a HTTPS communication so that API server will call by using an admission controller, right? So here this is a Kubernetes cluster. So first generate a certificate key pair using a CFSSL utility. So and go to the documentation, manage a TLS certificate, right? So here this is the what the certificate signing request I need to create by using CFSSL. So I copied the same JSON here, right here. Well, basically what exactly it is, my service is hello world SVC, right? And I wanted to expose this hello world SVC as alternate domain names. Maybe people can call this name and this one, anything. And my CNAME is this one, and whatever this algorithm and the size and etc. And this is my cluster IP, and this is my pod IP. That's what the cluster IP and the pod IP. So this will basically what I do. I'm in a CSR directory, right, which is this one. So what I will do is mkdir, I'll create one test directory, and cd go inside the test directory. Perfect. Now first step is to create this particular certificate signing request, which is as per the documentation, but I just modified the values right now. So I just enter here, right? Now it's created under the test directory. So let's go to the test directory. So there are two files are created, server.csr, server.key. Here server is my hello world server, right? Now once the certificate signing request is basically certificates are created, right, which is these two files are created, right, CSR and PEM file, right? CSR and PEM file. Now second is create a certificate signing request. So this is the actual process where this is a certificate signing request. Here my svc dot namespace is given as the name. So what I did is I created the similar file by copy paste here, hello world svc dot default. This is my name I given, and request. What is the I'm passing here? This server certificate base64 encoded I'm passing here. Signer. This is the most important. Who is the signer? learnwithgvr.io, which is this guy is completely a new Kubernetes not aware of. So why learnwithgvr? Let's consider this hello world application is developed by learnwithgvr company, and this hello world must serve the certificate, which is this is the external signer, and this external signer has to also recognized by the Kubernetes as well. That's the whole objective. And what is the purpose of usage is this one, which is everything is I copied from here, right? Perfect. So now I'll creating a CSR, which is just copy paste in the interest of time, so I can modify as well, right? Now I just did that, right? Perfect. And it's created. Now how to check that? Right? kubectl get CSR, hello world CSR is created, and 6 seconds back signer is who is the signer? learnwithgvr.io, and this still now Kubernetes not aware, and the certificate status is pending. By the way, who is created is the Venkat is created. I am the creator, right? Now kubectl describe CSR, right? So this is the when I describe the CSR, signer is definitely is external signer, not a Kubernetes default signer, right? So some organization, and these are the alternate domain names and IP address, which is now that's another step is once I created approve the certificate. If you wanted to approve the certificate, then it's very simple command, kubectl certificate approve and the CSR name, right? So here kubectl certificate approve, and what is my CSR name? This is the CSR name, right? When I do that approve and kubectl get CSR, see the status is pending to approved, but still the signer is a new guy. Kubernetes is not aware of this signer, right? Perfect. Now just clear. So now approve. Then next step is create a custom CA. Why we need to create a custom CA? Because here the signer is this signer I have to create this signer. So in order to create a new signer, there is a syntax is given. First you need to create a one file which is called a JSON file, right? This is this one. So just copy that, and my example signer is given, right? But what I did is, right, I just created learnwithgvr is a signer, some name, okay, just for the demo. Now let's look at here, right? As soon as I create, it created the 3 different files. Earlier these two server.csr, now 1 2 3 ca.py. So these files are created specific to the CA, which is this guy. Now next step is go to the slide, sign with the CA. Now my CA is created. Now I have to sign. How to sign that? Here is a command is given, which is I will copy. I have copied and just modified the values, right? So I will copy these values, and by the way, there is a sign configuration I have to create. Why the sign configuration is, whenever you are signing, what is the usage, what is the expiry, and it concern its profile name. You can create a multiple profile. So this is a simple configuration, sign config, which is given in the documentation. As per that I have created this sign configuration, right? So nothing new here. Then I need to pass it to the this test directory. Now I will have a command here, right? So I will just copy. By the way, let me explain. kubectl get CSR, this is the, so let's copy that, and yeah, so right, so this is a signed certificate. So kubectl get CSR, this is the certificate, and CFSSL sign with the ca.pem, ca.key pem, and sign configuration. So 3 values I am passing signing, right, which is this CA I am passing, and so that it's a sign, right? Now kubectl get CSR. Now let's see, right? So this is the one, and right now the next is, once you create the once you sign, you need to upload the sign certificate to the API object. Why you need to upload? You sign, but you need to let the Kubernetes system know that there is a new signer is created, right? For that the command is given by the is uploading is this is a command they given, and what I did is I just simply modified the certificate, right? So this is the one, right? I will explain what exactly this command will does, right? So now here, right? So, yeah, so here I need to just change the something. My CSR is this one, but CSR name is somehow changed. So one second, yeah, this name, it's not hello world CSR, it is a, this is the name, right? Hello world default. So get the CSR, and it's a certificate, and kubectl replace -ra. And what exactly this path is? API server path, where all the certificate signing requests will be located, which is a hello world with this name. It's a status. So I'm uploading back, right? So now when I enter here, right, it's done. So how to verify that? And by the way, kubectl replace and -ra will tell you about the what to do, what exactly it does. So if you wanted to check that, then kubectl replace, and then look for the help, and -ra URI to put to the server. So you are injecting into the server, right, whatever the signed certificate. That's what the uploading into the API object. And where you are uploading here in the previous tab, right? You are uploading into the, this is the API path, which is a certificate signing request path, right? Now kubectl get CSR. What the status is here? Approved and issued. That means first step approved and second is issued. So go to the slide here, right? Uploaded and it's approved and issued. Now next step is to just simply download the certificate. How to download the certificate? It's simple. This is a CSR, right? kubectl get CSR, and what is my CSR name? This is a CSR, right? And here is a command is given. So -o JSON path status.certificate, right? So if you look at here, this is the my certificate, but this certificate is not a base 64 encoded. So I need to just base 64 -d. This is a base 64 decoded certificate. How I wanted to download my locally as a server.crt, right? So now I'm downloading, right? Downloading in the sense, this is the last step I'm doing that, right? So right here, right? So sorry. So now Control C, right? Now after that server.crt. Perfect. Now when I do the server.crt, go here, server.crt is created. This is the certificate which is completely signed and issued, which this certificate can be used by my server. This is a completely fully authorized certificate, right? So now this is the one. Now the next step is create a secret and use in a pod, right? So now the next step is go to the documentation here. So why you need creating a secret? Because your pods maybe need this certificate. So what I will do is just to creating a certificate, right? So once I have this certificate, I can use it anywhere, right? So here, right? So kubectl create certificate, not a server, which is hello world server CRT. Just give some nice name, right? Now its secret is created. kubectl get secret, right? Hello world server CRT. This is the certificate which is created 5 seconds back, right? This certificate I can use it in my application, so that my application serve as a HTTP TLS, ready for the TLS communication with the API server, right? And this is a one example, and there is a second example as well, where I wanted to create basically one user as a Venkat kubeconfig user, right? So this is the second example. So kubeconfig get kubectl config, right? Get context. Only one context is there. I wanted to create a Venkat user called Venkat. So then you will be creating again, you will be creating a one key pair and raising a CSR, but here raising a CSR with what? Who is a signer? API server client, right? So let's do that quickly. These are the commands. So I'm creating, right? So now I'll just do, sorry, right? So now clear and then do that, right? It's done. Venkat.key file are created right here, right? Venkat.csr, Venkat.key. Now the next step is, right, now raise a certificate signing request. So here certificate signing request, what you are doing is just look at the carefully, right? Dev CSR you created, passing a Venkat.csr which is created just now, and who is the signer? Kube API server client, because here the purpose is you wanted to connect, right? kubectl get CSR. Now dev CSR is created, but who is the signer? Here is a different signer. It's a pending. How to approve that? kubectl, right? Right. So here is the command, right? So basically certificate approve Venkat. So kubectl, just kubectl certificate approve, not a Venkat, which is certificate name is dev CSR, right? So who is approving? Kubernetes admin. I am the approving, right? So if you go to look at the kubectl get CSR, what happened? Dev CSR is approved and issued. there is no signing additional step here. Why? Because I am using an existing signer for this one. Now I can download this certificate and use it in my kubeconfig file. How to do that? It's a simple command, right? See this is again the we did that, right? So just go here, right? kubectl get CSR. It's not a Venkat CSR name, so it's a dev CSR, right? And if you do that, this is a certificate where I can download, right? So here Venkat user CRT, perfect. Now what I can do is Venkat user CRT and Venkat key. These two files I can use as a kubeconfig user, which is kubectl config view -ra. Here is a user Kubernetes admin, right? I can create another user called a Venkat and use it as a Kubernetes user so that it will authorize. Of course it won't authorize, you need to add on top of that or back permissions and etc. Now quickly what I will do is I will create a role and role binding for the user which I am going to create. So I just created, right? So here so kubectl get role, there is a one role is created developer, and kubectl get a role binding, right? And what is the role binding? Role binding Venkat. So right, for this I just created this role binding. So the next step is quickly I will just create a kubeconfig. So basically here I have two files, right? Kubernetes CRT, which is assigned by the Kubernetes API server, and one is a key. So by using these two files I am going to create a kubeconfig user, so which is just to save the time I will just try to create this command one by one. This one and this kubeconfig, right? The user is created. Now the text is set context, right? And this is a kubeconfig, right? Now kubectl get kubectl config, right? Get context. Now you see there is a Venkat and as well as there is a Kubernetes admin. So you can just use this kubeconfig use context as a Venkat, right? Now is a Venkat. Now what the Venkat is allowed to do, he can list and delete, update pods. So kubectl get pods, right? Kubectl config current context, who I am connected, I am a Venkat. So this is the way you can achieve, you can restrict, you can make use of users the certificates, right? And here if you look at here kubectl config view -ra, right? So if you look at here yeah, users Kubernetes admin, this is admin, and if it is a Venkat specific client certificate and client data, this client certificate and client data is generated by using a MyCSR process. That's it for this session, and thank you for listening. Sorry for the long video, and let me know what you guys think about this particular Kubernetes certificate and CSR CA process. Thank you. Bye bye.